What if the strangest star in the universe held secrets that could rewrite everything we know about the cosmos? Meet Mira, a celestial enigma that defies the ordinary and challenges our understanding of the stars. This isn't just another twinkling light in the night sky. Mira is a cosmic marvel, a star that pulses, breathes, and even leaves a trail of stardust stretching across the galaxy. Its story is one of mystery, discovery, and wonder, and it's a story that could change the way we see the universe. From its dramatic changes in brightness to its comet-like tail, Mira is unlike anything else out there. So, what makes this star so extraordinary, and what can it teach us about the vast, ever-changing cosmos? Stay with us as we dive into the fascinating world of Mira, the strangest star in the universe, and uncover the secrets it holds. By the end of this journey, you'll see the night sky in a whole new light. Let's begin. Now turning to the story of Mira's discovery, we find ourselves in the year 1596, when astronomer David Fabricius first observed this peculiar star. At the time, Fabricius was studying the constellation Cetus, and he noticed a star that seemed to appear and disappear in the night sky. This behavior was unlike anything astronomers had ever recorded before. Initially, Fabricius thought it might be a new star, but its reappearance months later left him puzzled. This marked the first recorded observation of a variable star, a star whose brightness changes over time. The mystery deepened when, decades later, Johannes Hevelius, a Polish astronomer, studied the star more closely. He named it Mira, meaning wonderful in Latin, a fitting title for a star that defied explanation. Mira's variability challenged the prevailing belief that stars were fixed and unchanging. For centuries, the night sky was thought to be a static canvas, but Mira proved that stars could evolve, pulsate, and even vanish from sight. This discovery opened the door to a new understanding of the cosmos, one where stars were dynamic and ever-changing. Mira's importance cannot be overstated. It became the prototype for an entire class of variable stars, now known as Mira variables. These stars, like Mira, undergo regular changes in brightness due to their pulsating outer layers. The discovery of Mira not only reshaped early astronomical thought, but also laid the groundwork for modern studies of stellar evolution. As we move forward, we'll explore what makes Mira's pulsation so unique and how it continues to captivate astronomers to this day. Now turning to the characteristics of Mira, let's dive into what makes this star so extraordinary. Mira is classified as a red giant, a type of star that has exhausted the hydrogen fuel in its core and expanded to an enormous size. In fact, Mira is estimated to be around 300 times larger than our Sun, making it a true giant in the cosmic landscape. Despite its immense size, Mira's mass is only slightly greater than that of the Sun, which means it's relatively lightweight for its size. This combination of vast size and low density gives Mira its distinctive appearance and behavior. Mira's temperature is another fascinating aspect of its nature. While its core remains incredibly hot, its outer layers are much cooler, giving it a reddish hue that's typical of red giants. This cooler surface temperature, combined with its massive size, makes Mira one of the brightest stars in the constellation Cetus, also known as the Whale. Cetus is a sprawling constellation in the night sky, and Mira stands out as one of its most intriguing inhabitants. What truly sets Mira apart, however, is its variability. Unlike most stars which shine with a steady light, Mira's brightness fluctuates dramatically over a period of approximately 332 days. At its brightest, Mira can be seen with the naked eye, but as it dims, it becomes invisible without the aid of a telescope. This pulsation, caused by the expansion and contraction of its outer layers, makes Mira a prototype for an entire class of variable stars. Its unique behavior has captivated astronomers for centuries and continues to be a key subject of study in understanding the life cycles of stars. As we explore further, we'll uncover the mechanisms behind Mira's pulsation, and how this incredible star continues to shape our understanding of the universe. Now turning to Mira's variability, let's explore what makes this star's behavior so unique and captivating. Mira's brightness doesn't stay constant like most stars we observe in the night sky. Instead, it undergoes dramatic changes over a cycle of approximately 332 days. This pulsation cycle is one of the most defining features of Mira and has earned it the title of a prototype for an entire class of stars known as Mira variables. During its cycle, Mira's brightness can vary by an astonishing amount. At its peak, it becomes one of the brightest stars in its constellation, Cetus, visible to the naked eye. But as it dims, it fades so dramatically that it disappears from view without the help of a telescope. This incredible fluctuation is caused by the star's outer layers expanding and contracting, a process driven by the complex interplay of internal pressures and temperatures. As Mira expands, its surface cools, causing it to glow with a reddish hue and appear brighter. When it contracts, the surface heats up slightly, but the overall brightness diminishes as the star shrinks in size. What's truly remarkable is that Mira's variability isn't just a random occurrence, it's a predictable pattern. Astronomers have been able to track its pulsation cycle with remarkable precision, making it a cornerstone in the study of variable stars. This predictability has allowed scientists to classify Mira as the archetype of its class, giving rise to the term Mira variables for other stars that exhibit similar behavior. Mira's variability isn't just a fascinating cosmic phenomenon, it's also a window into the inner workings of stars. By studying how Mira pulsates, astronomers gain insights into the processes that govern stellar evolution, particularly in the later stages of a star's life. This makes Mira not just a star to admire, but a vital tool for understanding the universe. As we move forward, we'll delve deeper into the science behind Mira's pulsation, uncovering the mechanisms that drive this extraordinary behavior and what it reveals about the life cycles of stars like Mira. Now turning to the science behind Mira's pulsation, let's uncover the fascinating mechanisms that drive this star's rhythmic expansion and contraction. At the heart of Mira's variability lies a delicate balance between the forces of gravity and the energy produced within its core. As Mira burns through its fuel, it undergoes a process known as helium fusion, where helium atoms are fused into heavier elements like carbon and oxygen. This fusion releases an immense amount of energy, which creates outward pressure, counteracting the inward pull of gravity. When the energy from helium fusion builds up, it causes Mira's outer layers to expand, much like a balloon being inflated. As these layers stretch outward, they cool down, giving the star its characteristic reddish glow and making it appear brighter in the night sky. However, this expansion doesn't last forever. Once the energy from fusion is depleted, gravity takes over, pulling the outer layers back inward. This contraction heats up the star's surface slightly, but because the star is now smaller, its overall brightness diminishes. This cycle of expansion and contraction repeats itself over a period of approximately 332 days, creating the predictable pattern of variability that astronomers have come to rely on. What's truly remarkable is how this process provides a glimpse into the internal dynamics of stars. Mira's pulsation is a direct result of the interplay between its core's energy production and the gravitational forces acting on its outer layers. By studying this behavior, scientists can better understand how stars like Mira evolve, especially as they approach the later stages of their lives. Mira's pulsation also highlights the role of helium fusion in shaping a star's destiny. As helium is converted into heavier elements, the star's core becomes denser and hotter, eventually leading to significant changes in its structure. This process not only drives Mira's variability, but also sets the stage for its eventual transformation into a white dwarf. By unraveling the science behind Mira's pulsation, we gain a deeper appreciation for the intricate processes that govern the lives of stars and the universe as a whole. As we continue, we'll explore another extraordinary feature of Mira, its comet-like tail, a phenomenon that adds yet another layer of intrigue to this already fascinating star. Now turning to one of Mira's most astonishing features, let's explore its comet-like tail, a breathtaking trail of gas and dust stretching an incredible 13 light-years across space. This remarkable feature was first discovered in 2007 by the GALEX satellite, a space telescope designed to observe ultraviolet light. What GALEX captured was nothing short of extraordinary. A glowing tail of material streaming behind Mira as it hurtles through the Milky Way at an astonishing speed. This tail is not just a random collection of debris, it's a direct result of Mira's interaction with the interstellar medium, the sparse gas and dust that fill the space between stars. As Mira moves through this medium, its powerful stellar winds, which are streams of charged particles ejected from its surface, collide with the surrounding material. These winds push the interstellar gas and dust outward, creating a wake that forms the tail. The tail's immense length and structure provide valuable insights into how stars like Mira lose mass and influence their surroundings. What makes Mira's tail particularly fascinating is its composition. The tail is rich in elements like carbon and oxygen, which are produced in Mira's core and expelled into space through its stellar winds. This process not only shapes the tail but also enriches the interstellar medium with heavy elements, contributing to the chemical evolution of the galaxy. By studying the tail, astronomers can learn more about how stars like Mira distribute these essential building blocks of planets and life throughout the cosmos. The discovery of Mira's tail has also shed light on the star's motion through space. Mira is traveling at an unusually high velocity, and its rapid movement plays a key role in shaping the tail. As the star plows through the interstellar medium, it creates a bow shock, a kind of cosmic ripple that compresses the material ahead of it, while the tail trails behind like a cosmic banner. This dynamic interaction highlights the complex relationship between stars and their environments, offering a glimpse into the forces that shape our galaxy. As we delve deeper into Mira's mysteries, we'll next explore how this tail forms and what it tells us about the life cycle of stars like Mira. The story of Mira's tail is not just about a star's journey through space, it's about the profound impact that even a single star can have on the universe around it. Now turning to the formation of Mira's tail, let's break down the fascinating mechanisms that create this cosmic phenomenon. At the heart of this process are Mira's powerful stellar winds, streams of charged particles that are constantly being ejected from the star's surface. These winds are driven by the intense energy generated within Mira, particularly during its pulsation cycles when the star expands and contracts. As these winds surge outward, they collide with the sparse gas and dust that make up the interstellar medium, the material that fills the space between stars. This collision is where the magic happens. The stellar winds push against the interstellar medium, compressing and heating the material in their path. Over time, this interaction creates a wake of gas and dust that trails behind Mira as it moves through space. The result is the stunning 13 light-year-long tail we observe today. But it's not just the stellar winds at work. Here, Mira's rapid motion through the galaxy plays a crucial role too. The star is traveling at an astonishing speed, and this high velocity amplifies the interaction between its winds and the interstellar medium, stretching the tail to its remarkable length. What makes this process even more intriguing is what it reveals about the life cycle of stars like Mira. As a red giant nearing the end of its life, Mira is shedding its outer layers, losing mass at an incredible rate. The tail is a visible record of this mass loss, a cosmic fingerprint that tells the story of a star in transition. By studying the tail, astronomers can piece together how Mira is evolving and how it will eventually transform into a white dwarf, the final stage of its stellar journey. The tail also provides a unique window into the broader processes that shape galaxies. The elements expelled by Mira, carbon, oxygen, and others, are essential building blocks for new stars, planets, and even life. As these elements are dispersed into the interstellar medium, they contribute to the chemical enrichment of the galaxy, setting the stage for future generations of stars and planetary systems. In this way, Mira's tail is not just a beautiful cosmic feature, it's a vital part of the ongoing story of the universe. As we continue to unravel the mysteries of Mira, the next chapter of our exploration will focus on the star's motion through space and how this high-speed journey influences its interactions with the surrounding environment. The tale of Mira's tail is far from over, and each discovery brings us closer to understanding the profound impact of stars on the cosmos. Now turning to Mira's motion through space, let's explore how this star's incredible speed and trajectory shape its cosmic journey. Mira is racing through the Milky Way at an astonishing velocity, traveling at hundreds of thousands of kilometers per hour. This rapid movement isn't just a random occurrence, it's a key factor in the formation of its spectacular tail and its interactions with the surrounding interstellar material. As Mira hurtles through the galaxy, it doesn't move in isolation. The space between stars is filled with a thin, diffuse medium of gas and dust known as the interstellar medium. Mira's high-speed journey means it's constantly colliding with this material, creating a dynamic interplay that shapes its environment. The star's stellar winds, which we discussed earlier, are pushed outward with tremendous force, but it's Mira's motion that amplifies their impact. As the star moves, these winds sweep through the interstellar medium, compressing and heating the material in their path. This process creates the long, glowing tail that trails behind Mira, stretching an incredible 13 light-years across the cosmos. But Mira's motion does more than just create a tail. It also influences how the star interacts with its surroundings. The high velocity means that Mira is effectively plowing through the interstellar medium, leaving a wake of disturbed material in its path. This interaction isn't just a one-way street. The interstellar medium also exerts a subtle drag on Mira, slowing it down ever so slightly over time. This drag effect is a reminder that even in the vast emptiness of space, nothing moves without consequence. What's truly fascinating is how Mira's motion provides clues about its past and future. By studying the star's trajectory, astronomers can trace its path back through the galaxy, piecing together where it might have originated. At the same time, Mira's speed and direction offer insights into where it's headed and how it will continue to evolve. As it moves, it continues to shed its outer layers, enriching the interstellar medium with elements that will one day form new stars and planets. Mira's journey through space is a testament to the dynamic nature of the universe. It's a reminder that even the stars are in constant motion, shaping and being shaped by the cosmos around them. As we continue to follow Mira's path, the next chapter of our exploration will delve into the star's unique chemical composition and how it contributes to the cosmic tapestry of the Milky Way. The story of Mira is far from over, and each discovery brings us closer to understanding the intricate dance of stars in the universe. Now turning to Mira's chemical composition, let's uncover what makes this star a cosmic alchemist, transforming simple elements into the building blocks of the universe. Mira's core is a furnace of nuclear fusion where hydrogen atoms are fused into helium, and helium, in turn, is transformed into heavier elements like carbon and oxygen. These elements are not just byproducts of Mira's fiery heart, they are the very essence of its contribution to the cosmos. As a red giant, Mira is in a late stage of stellar evolution, where its core has exhausted its hydrogen fuel and begun burning helium. This process, known as helium fusion, creates carbon and oxygen which accumulate in the star's core, but Mira doesn't keep these elements to itself. Through its powerful stellar winds and pulsations, it ejects these newly forged elements into space, scattering them across the interstellar medium. This process is a vital part of the cosmic cycle, as these elements will eventually become part of new stars, planets, and even life itself. What's remarkable about Mira is the sheer abundance of carbon and oxygen it produces. These elements are essential for the formation of complex molecules, from the carbon dioxide in our atmosphere to the oxygen we breathe. Mira's role in enriching the interstellar medium with these elements is a testament to the interconnectedness of the universe. Every atom of carbon or oxygen in your body may have once been forged in the heart of a star like Mira billions of years ago. But Mira's chemical contributions don't stop there. As it continues to shed its outer layers, it also releases trace amounts of other elements, such as nitrogen and silicon, into the surrounding space. These elements, though less abundant, play crucial roles in the formation of planetary systems and the chemistry of life. Mira's winds carry these materials far and wide, seeding the galaxy with the ingredients for future cosmic creations. The study of Mira's chemical composition not only reveals the inner workings of this enigmatic star, but also provides a window into the processes that shape the universe. By understanding how stars like Mira produce and distribute elements, astronomers can piece together the story of how galaxies evolve and how the building blocks of life are scattered across the cosmos. As we continue to explore Mira's mysteries, the next chapter will take us deeper into its role in stellar evolution and what it teaches us about the life cycles of stars. The journey through Mira's story is a journey through the very fabric of the universe itself. Now turning to Mira's role in stellar evolution, let's explore how this remarkable star serves as a cosmic blueprint for understanding the final chapters of a star's life. Mira, as a red giant, is in the twilight of its existence, undergoing dramatic changes that will eventually lead to its transformation into a white dwarf. This process is not just a fascinating spectacle, it's a critical case study for astronomers seeking to unravel the mysteries of how stars age and die. At this stage, Mira has already exhausted the hydrogen fuel in its core, forcing it to burn helium instead. This helium fusion creates heavier elements like carbon and oxygen, which accumulate in its core while its outer layers expand and cool, giving it the characteristic red glow of a giant star. But this phase is temporary. Over time, Mira will shed its outer layers entirely, leaving behind a dense, hot core, a white dwarf. This transition is a key part of the stellar life cycle, and Mira's journey offers a glimpse into the fate of countless other stars, including our own Sun. What makes Mira particularly valuable to scientists is its variability and the way it interacts with its surroundings. As it pulsates and ejects material into space, it provides a real-time laboratory for studying how stars lose mass and influence their environments. This mass loss is crucial because it determines how quickly a star transitions from a red giant to a white dwarf. For Mira, this process is already well underway, with its stellar winds and pulsations scattering its outer layers across the cosmos. The implications of Mira's evolution extend far beyond itself. By studying Mira, astronomers can better predict the future of other stars in similar stages of life. For example, our Sun will one day follow a similar path, expanding into a red giant before shedding its outer layers and becoming a white dwarf. Understanding Mira's behavior helps us prepare for what lies ahead for our own star and the countless others like it. Moreover, Mira's transformation has profound implications for the universe as a whole. The material it ejects enriches the interstellar medium, providing the raw ingredients for new stars, planets, and even life. This cycle of stellar birth, death, and rebirth is a fundamental process that shapes the cosmos. Mira's role in this cycle underscores the interconnectedness of all things in the universe, from the smallest atoms to the largest galaxies. As we continue to study Mira, we gain not only a deeper understanding of its own story, but also a clearer picture of the broader processes that govern stellar evolution. The next chapter of Mira's journey will take us even further as we explore how its interactions with its binary companion, Mira B, influence its evolution and the surrounding cosmic environment. The story of Mira is far from over, and each discovery brings us closer to unraveling the mysteries of the stars. Now turning to Mira's impact on astronomy, let's explore how this extraordinary star has left an indelible mark on our understanding of the cosmos. Mira's discovery in the late 16th century marked a pivotal moment in the history of astronomy. As the first variable star ever recorded, it challenged the prevailing belief that stars were unchanging and eternal. This revelation opened the door to a new field of study, variable star astronomy, and forever altered how we perceive the universe. Mira's variability, with its dramatic changes in brightness over a period of approximately 332 days, provided astronomers with a unique opportunity to study the life cycles of stars. By observing Mira, scientists began to understand that stars are not static objects but dynamic entities that evolve over time. This insight laid the groundwork for modern astrophysics, helping us piece together the complex processes that govern stellar behavior. Beyond its variability, Mira's role as a prototype for the Mira variable star class has been instrumental in advancing our knowledge of stellar evolution. Stars like Mira serve as cosmic laboratories, offering clues about the mechanisms behind pulsation, mass loss, and the eventual fate of stars. By studying Mira, astronomers have been able to develop models that explain how stars transition from one stage of life to another, from red giants to white dwarfs, and how they enrich the interstellar medium with heavy elements. Mira's influence extends even further, shaping our understanding of the universe on a grand scale. Its discovery and subsequent study have inspired generations of astronomers to explore the mysteries of the cosmos. From the development of new observational techniques to the creation of advanced telescopes, Mira has been a driving force behind many of the tools and technologies we use today to study the stars. Perhaps most importantly, Mira has taught us that the universe is a place of constant change and transformation. Its pulsations and mass loss remind us that even the most seemingly stable objects in the sky are part of a dynamic and ever-evolving system. This understanding has profound implications for our place in the universe, encouraging us to look beyond our own world and consider the broader processes that shape the cosmos. As we reflect on Mira's impact, it's clear that this star is more than just a celestial curiosity. It's a cornerstone of modern astronomy. Its story continues to inspire and inform, reminding us of the endless wonders waiting to be discovered in the night sky. And as we turn our gaze to the next chapter of Mira's journey, we'll explore how its interactions with its binary companion, Mira B, further illuminate the intricate dance of stellar evolution. Now turning to Mira's place in mythology and culture, we uncover a fascinating layer of its story that transcends the realm of science. Named after the Latin word for wonderful, Mira has long captured the imagination of humanity, not just as a celestial object but as a symbol of mystery and inspiration. Its name alone reflects the awe it has inspired for centuries, a testament to its unique place in both the night sky and the human psyche. In various mythologies, Mira has been woven into stories that reflect its enigmatic nature. In some traditions, it was seen as a celestial omen, its changing brightness interpreted as a sign from the heavens. For others, it represented the eternal dance of creation and destruction, a reminder of the cyclical nature of the universe. These interpretations highlight how Mira's variability resonated with ancient cultures, offering a cosmic mirror to their own beliefs and philosophies. Beyond mythology, Mira has also left its mark on art and literature. Its pulsating light and mysterious behavior have inspired poets, painters, and storytellers to explore themes of transformation, beauty, and the unknown. In the world of science fiction, Mira has often been depicted as a beacon of discovery, a star that holds the key to unlocking the secrets of the universe. Its presence in creative works underscores its ability to spark curiosity and wonder, bridging the gap between science and the arts. Mira's influence extends to the realm of scientific curiosity as well. Its discovery and subsequent study have inspired countless individuals to look up at the night sky and ponder the mysteries of the cosmos. From amateur astronomers to professional scientists, Mira has served as a reminder that the universe is full of surprises, waiting to be uncovered by those who dare to explore. As we reflect on Mira's cultural significance, it's clear that this star is more than just a scientific marvel. It's a source of inspiration that transcends disciplines and generations. Its story reminds us that the stars above are not just points of light but symbols of our shared curiosity and creativity. And as we continue to explore the wonders of Mira, we'll see how its legacy continues to shape our understanding of the universe and our place within it. Now turning to the practical side of Mira's story, let's explore how you can observe this fascinating star for yourself. For amateur astronomers, Mira offers a unique opportunity to witness the dynamic nature of the cosmos firsthand. But to catch a glimpse of this celestial wonder, you'll need to know when and how to look. The best time to observe Mira is during its peak brightness, which occurs roughly every 332 days as part of its pulsation cycle. This means timing is everything. To find out when Mira will be at its brightest, you can consult astronomical calendars or apps that track variable stars. Generally, Mira is most visible in the constellation Cetus, the Whale, which is best seen in the night sky during the autumn and winter months in the northern hemisphere. When it comes to tools, you don't need a high-powered telescope to observe Mira. A good pair of binoculars or a small telescope will suffice, especially when the star is near its maximum brightness. However, as Mira dims, you may need more advanced equipment to keep track of its changes. For those who enjoy recording their observations, keeping a log of Mira's brightness over time can be a rewarding way to contribute to citizen science projects. One of the most intriguing aspects of observing Mira is watching its brightness change. At its brightest, Mira can reach a magnitude of around 2, making it easily visible to the naked eye. But as it dims, it can fade to a magnitude of 10 or lower, requiring optical aid to see. This dramatic variability is what makes Mira such a captivating target for stargazers. By tracking its changes, you'll gain a deeper appreciation for the dynamic processes that govern the lives of stars. As you prepare to observe Mira, remember that patience is key. Its brightness changes gradually, so regular observations over weeks or months will give you the best sense of its behavior. And while you're waiting for Mira to shine at its brightest, take a moment to appreciate the broader night sky. After all, Mira is just one of countless stars that remind us of the vastness and wonder of the universe. With these tips in mind, you're ready to embark on your own journey of observing Mira. As you peer into the night sky, you'll not only witness the beauty of this remarkable star, but also connect with the centuries of curiosity and discovery that it has inspired. And as we move forward, we'll explore another fascinating aspect of Mira's story, its binary companion Mira B, and the intriguing dynamics of their cosmic dance. Now turning to another fascinating chapter in Mira's story, let's meet its binary companion Mira B. This small but significant star plays a crucial role in the cosmic dance that defines the Mira system. Mira B is a white dwarf, a dense remnant of a star that has exhausted its nuclear fuel and collapsed into a compact object. Despite its small size, Mira B exerts a powerful influence on its larger companion, Mira, creating a dynamic and intriguing relationship. The interaction between Mira and Mira B is a prime example of how binary star systems operate. As Mira pulsates and sheds material into space, some of this gas and dust is captured by Mira B's gravitational pull. This process, known as mass transfer, leads to the formation of an accretion disk around Mira B. Over time, the material in this disk spirals inward, eventually falling onto the surface of the white dwarf. This interaction not only fuels Mira B, but also provides astronomers with valuable insights into the behavior of binary systems. One of the most remarkable aspects of this relationship is how it influences Mira's evolution. The mass loss caused by Mira's pulsations and the gravitational tug of Mira B accelerate the aging process of the red giant. As Mira continues to shed its outer layers, it moves closer to the final stages of its life, eventually destined to become a white dwarf itself. This interplay between the two stars offers a unique window into the life cycles of stars and the complex dynamics of binary systems. Studying Mira and Mira B also helps scientists understand the broader implications of mass transfer in binary systems. These interactions can lead to dramatic events such as nova or even supernova, depending on the conditions. By observing the Mira system, astronomers can piece together the processes that drive these cosmic phenomena, shedding light on the evolution of stars and the enrichment of the interstellar medium. As we continue to explore the mysteries of Mira and its companion, we gain a deeper appreciation for the intricate relationships that shape the universe. The story of Mira and Mira B is not just about two stars orbiting each other, it's a testament to the interconnectedness of cosmic processes and the endless wonders waiting to be discovered. With this understanding, we're ready to delve deeper into the dynamics of their interaction and what it reveals about the universe at large. Now turning to the intricate dance between Mira and its companion, Mira B, we uncover a cosmic relationship that shapes the destiny of both stars. The interaction between these two celestial bodies is a delicate balance of gravity, mass, and energy, creating a system that is as dynamic as it is fascinating. At the heart of this relationship is the process of mass transfer, where Mira, the pulsating red giant, loses material from its outer layers, and Mira B, the white dwarf, captures some of this material through its gravitational pull. As Mira pulsates, it ejects gas and dust into space, forming a stellar wind that flows outward. Mira B, with its strong gravitational field, intercepts a portion of this material, drawing it into an accretion disk that swirls around the white dwarf. Over time, the material in this disk spirals inward, eventually falling onto the surface of Mira B. This process not only fuels Mira B, but also generates intense heat and radiation, making the white dwarf shine brightly in the process. The mass transfer between Mira and Mira B has profound implications for both stars. For Mira, the loss of material accelerates its evolution, pushing it closer to the final stages of its life. As it continues to shed its outer layers, Mira is destined to transform into a planetary nebula, leaving behind a white dwarf remnant. For Mira B, the accretion of material from its companion can lead to dramatic events, such as thermonuclear explosions known as nova, which occur when the accumulated material on the white dwarf's surface ignites in a sudden burst of energy. These interactions also provide astronomers with a unique laboratory to study the physics of binary star systems. By observing the Mira B system, scientists can gain insights into the mechanisms of mass transfer, the formation of accretion disks, and the processes that drive stellar evolution. The dynamics of this system offer a glimpse into the complex interplay of forces that govern the lives of stars and the broader universe. As we delve deeper into the interactions between Mira and Mira B, we begin to see how these two stars are not just isolated objects but part of a larger cosmic narrative. Their relationship highlights the interconnectedness of celestial processes and the profound impact that binary systems can have on the evolution of stars and the enrichment of the interstellar medium. With this understanding, we're ready to explore what the future holds for Mira and its companion, and how their story continues to unfold in the vast expanse of the universe. Now turning to the future of Mira, we find ourselves peering into the cosmic timeline of this extraordinary star. Mira, as it continues its journey through the universe, is destined for a dramatic transformation. Over the next several 100,000 years, Mira will exhaust the remaining fuel in its core, leading to the final stages of its life as a red giant. As it sheds its outer layers, these expelled materials will form a glowing shell of gas and dust, creating what astronomers call a planetary nebula. This nebula will be a breathtaking sight, illuminated by the intense ultraviolet radiation from the exposed core of Mira, which will have collapsed into a dense, hot white dwarf. The timescales involved in this process are vast, spanning hundreds of thousands of years. During this period, Mira will continue to lose mass at an accelerated rate, enriching the surrounding interstellar medium with elements like carbon and oxygen. These elements, forged in the heart of Mira, will eventually become the building blocks for new stars, planets, and even life itself. The planetary nebula phase, though relatively brief on cosmic timescales, will leave a lasting imprint on the galaxy, contributing to the cycle of stellar birth and death that shapes the universe. As Mira transitions into a white dwarf, it will no longer undergo nuclear fusion. Instead, it will slowly cool and fade over billions of years, becoming a faint remnant of its former self. This cooling process will mark the end of Mira's active life, but its legacy will endure. The materials it has ejected into space will continue to influence the formation of new celestial objects, ensuring that Mira's story remains woven into the fabric of the cosmos. The transformation of Mira also has implications for its companion, Mira B. As Mira evolves, the dynamics of their binary system will shift. The mass transfer between the two stars will eventually cease, leaving Mira B to orbit the white dwarf remnant. This change will alter the balance of their relationship, offering astronomers a unique opportunity to study the late stages of binary star evolution. Looking ahead, Mira's future serves as a reminder of the ever-changing nature of the universe. Its journey from a pulsating red giant to a planetary nebula and finally to a white dwarf highlights the intricate processes that govern the lives of stars. As we continue to observe and study Mira, we gain not only a deeper understanding of stellar evolution, but also a profound appreciation for the interconnectedness of all cosmic phenomena. With this glimpse into Mira's future, we're ready to explore how its contributions to the interstellar medium shape the broader universe. Now turning to Mira's contribution to the interstellar medium, we uncover how this remarkable star plays a vital role in shaping the chemical landscape of the universe. As Mira pulsates and sheds its outer layers, it releases vast amounts of gas and dust into space. This material, rich in heavy elements like carbon and oxygen, becomes part of the interstellar medium, the cosmic reservoir of matter that fills the spaces between stars. These elements, forged in the intense heat of Mira's core, are essential building blocks for new stars, planets, and even the molecules necessary for life. Stars like Mira act as cosmic recyclers, transforming simple elements into more complex ones through nuclear fusion. When these stars reach the end of their lives, they expel these enriched materials into their surroundings. Over time, these elements mix with the interstellar medium, creating a more diverse and chemically rich environment. This process is crucial for the formation of future generations of stars and planetary systems. Without the contributions of stars like Mira, the universe would lack the variety of elements needed to form rocky planets, organic molecules, and the conditions for life as we know it. The enrichment of the interstellar medium by Mira and similar stars also drives the chemical evolution of galaxies. As new stars form from this enriched material, they inherit a more complex chemical makeup, which influences their development and the potential for planetary systems around them. This cycle of stellar birth, death, and rebirth ensures that galaxies continue to evolve, becoming more chemically diverse over billions of years. Mira's role in this cosmic cycle highlights the interconnectedness of all celestial phenomena. Its contributions remind us that even a single star can have a profound impact on the broader universe. As we continue to study Mira and its effects on the interstellar medium, we gain deeper insights into the processes that shape the cosmos and our place within it. With this understanding, we're ready to explore how Mira's dynamic environment might influence the search for exoplanets and the potential for life in such systems. Now turning to the fascinating intersection of Mira and exoplanet research, we delve into the possibilities and challenges of discovering planets in such a dynamic stellar environment. Mira's pulsating nature and its comet-like tail create a turbulent and ever-changing region around it, making the search for exoplanets both intriguing and complex. While most exoplanet discoveries have been made around stable, main-sequence stars, Mira's unique characteristics open up a new frontier for exploration. The extreme variability of Mira's brightness poses a significant challenge for detecting exoplanets. Traditional methods, such as the transit technique, rely on observing small dips in a star's brightness as a planet passes in front of it. However, Mira's brightness fluctuates dramatically over its 332-day cycle, making it difficult to distinguish between the star's natural variability and the subtle signals of an orbiting planet. Additionally, the intense stellar winds and the dense tail of gas and dust surrounding Mira could obscure potential planetary signals, further complicating detection efforts. Despite these challenges, studying exoplanets around Mira-like stars offers unique opportunities. Planets in such systems would experience extreme conditions, from intense radiation to rapid changes in temperature and gravitational forces. These environments could provide valuable insights into the resilience and adaptability of planetary systems under stress. For instance, a planet orbiting Mira might have a highly elliptical orbit, experiencing dramatic shifts in climate as it moves closer to and farther from the star. Such a scenario could help scientists understand the limits of habitability and the potential for life in extreme cosmic settings. Moreover, the chemical richness of Mira's surroundings could influence the composition of any planets that form in its vicinity. The heavy elements ejected by Mira, such as carbon and oxygen, might contribute to the formation of rocky planets with complex atmospheres. These planets could serve as natural laboratories for studying the chemical processes that lead to the emergence of life. While the likelihood of finding habitable worlds around Mira itself is low due to its unstable nature, similar stars in less extreme phases of their evolution might host more stable environments conducive to life. As we continue to advance our observational technologies, such as the James Webb Space Telescope, the potential for discovering exoplanets around variable stars like Mira grows. These discoveries could revolutionize our understanding of planetary formation and evolution, shedding light on the diversity of worlds that exist in the universe. With Mira as a guide, we are reminded that even the most chaotic and unpredictable corners of the cosmos hold secrets waiting to be uncovered. As we move forward, the next chapter of our exploration takes us into the realm of modern astrophysics, where cutting-edge research continues to unravel the mysteries of this enigmatic star. Now turning to the cutting-edge realm of modern astrophysics, we explore how advanced technology has transformed our understanding of Mira. Space telescopes like Hubble and the James Webb Space Telescope have become indispensable tools in unraveling the mysteries of this enigmatic star. These powerful instruments allow scientists to observe Mira in unprecedented detail, capturing its pulsations, its comet-like tail, and the intricate dynamics of its surroundings. One of the most significant breakthroughs has been the ability to study Mira's tail in greater depth. The Hubble Space Telescope, with its high-resolution imaging capabilities, has provided stunning visuals of the 13-light-year-long trail of gas and dust. These observations have revealed how Mira's rapid motion through space interacts with the interstellar medium, creating a tail that resembles a cosmic wake. The James Webb Space Telescope, with its infrared sensitivity, has taken this exploration even further, allowing researchers to peer through the dense clouds of dust and analyze the chemical composition of the tail. This has shed light on the processes by which Mira enriches the interstellar medium with heavy elements like carbon and oxygen. modern technology has also deepened our understanding of Mira's pulsation mechanism. By combining data from ground-based observatories and space telescopes, scientists have been able to track the star's brightness variations with remarkable precision. This has led to new insights into the internal processes driving Mira's pulsations, including the role of helium fusion and the interplay between its expanding and contracting outer layers. These findings have not only enhanced our knowledge of Mira, but also provided a framework for understanding other variable stars in the universe. Another exciting area of research involves the study of Mira's binary companion, Mira B. Advanced instruments have allowed astronomers to observe the interactions between the two stars, including the transfer of mass from Mira to its white dwarf companion. These observations have provided valuable clues about the evolution of binary star systems and the role they play in shaping the cosmos. As we continue to push the boundaries of astrophysics, Mira remains a focal point for discovery. The combination of cutting-edge technology and innovative research methods has opened new windows into the life cycle of stars, the dynamics of stellar winds, and the chemical evolution of galaxies. With each new observation, we come closer to unraveling the secrets of this extraordinary star, reminding us that even the most familiar objects in the night sky still hold surprises waiting to be uncovered. Moving forward, we turn our attention to how Mira has inspired creativity and imagination, leaving an indelible mark on art, culture, and our collective fascination with the cosmos. Now turning to the intersection of science and creativity, we explore how Mira has left its mark on art, literature, and popular culture. This enigmatic star, with its pulsating brilliance and comet-like tail, has long captured the imagination of artists and storytellers, becoming a symbol of cosmic wonder and mystery. Its unique characteristics have inspired countless works, from science fiction novels to breathtaking visual art, bridging the gap between the scientific and the artistic. In science fiction, Mira has often been depicted as a beacon of exploration or a harbinger of cosmic events. Writers have imagined it as the home of advanced civilizations, the setting for interstellar adventures, or even a celestial entity with a will of its own. Its variability and dramatic changes in brightness have made it a compelling metaphor for transformation and the unpredictable nature of the universe. These portrayals not only entertain but also spark curiosity, encouraging readers to look up at the night sky and ponder the mysteries it holds. Visual artists, too, have been drawn to Mira's ethereal beauty. Paintings, digital art, and even sculptures have sought to capture the star's pulsating glow and its sweeping tail of gas and dust. These works often emphasize the contrast between Mira's fiery core and the delicate, almost ghostly trail it leaves behind, creating a sense of both power and fragility. By translating scientific observations into visual masterpieces, artists help make the wonders of the cosmos accessible to a broader audience, fostering a deeper appreciation for the universe. Mira's influence extends to film and television as well, where it has appeared as a backdrop for dramatic space scenes or as a central element in stories about discovery and exploration. Its name, derived from the Latin word for wonderful, perfectly encapsulates its role as a source of inspiration and awe. Whether depicted as a distant star in a galaxy far away or as a key plot device in a futuristic narrative, Mira continues to captivate audiences and fuel their fascination with the cosmos. Beyond its artistic impact, Mira has also played a significant role in sparking public interest in astronomy. Its variability makes it a favorite among amateur stargazers, who eagerly track its changes in brightness and share their observations with others. Educational programs and planetarium shows often feature Mira as an example of the dynamic and ever-changing nature of the universe, inspiring the next generation of scientists and dreamers. As we reflect on Mira's influence on art and media, it's clear that this star is more than just a celestial object. It's a source of inspiration that transcends disciplines. By blending science and creativity, Mira reminds us of the profound connection between the cosmos and human imagination. Moving forward, we'll delve into the lingering mysteries surrounding this extraordinary star, exploring the questions that continue to intrigue scientists and stargazers alike. Now turning to the mysteries that still surround Mira, we find ourselves faced with questions that continue to challenge even the most advanced scientific minds. Despite decades of study, the exact mechanisms behind Mira's variability and the formation of its spectacular tail remain topics of intense research and debate. What drives this star to pulsate so dramatically, and how does it create such an extraordinary trail of gas and dust? These are just some of the puzzles that keep astronomers and astrophysicists captivated. One of the most intriguing aspects of Mira is its variability. While we know that its brightness fluctuates over a period of approximately 332 days, the precise processes that cause these changes are not fully understood. Scientists believe that the star's outer layers expand and contract due to internal pressures and the fusion of helium in its core, but the exact interplay of these forces remains a mystery. Advanced computer models and observations from space telescopes are helping to shed light on these dynamics, but there is still much to learn about how Mira's internal engine drives its dramatic transformations. Equally puzzling is the formation of Mira's tail, a 13 light-year-long stream of gas and dust that trails behind the star as it hurtles through space. While we know that stellar winds and Mira's rapid motion contribute to this phenomenon, the details of how the tail forms and evolves over time are still unclear. Researchers are particularly interested in understanding how the star's pulsations influence the release of material into its surroundings and how this material interacts with the interstellar medium. These interactions could hold clues to the broader processes that shape the life cycles of stars and the evolution of galaxies. Ongoing research using cutting-edge technology, such as the Hubble Space Telescope and the James Webb Space Telescope, is providing new insights into these mysteries. By studying Mira in different wavelengths of light, scientists can observe the star's behavior in unprecedented detail, revealing hidden aspects of its structure and activity. These observations are not only deepening our understanding of Mira, but also opening up new avenues for exploring similar stars and their roles in the cosmos. As we look to the future, the potential for groundbreaking discoveries about Mira is immense. Each new observation brings us closer to unraveling the secrets of this enigmatic star, and with every answer comes a host of new questions. What other surprises does Mira hold? Could it teach us more about the origins of heavy elements or the dynamics of binary star systems? The journey to uncover these answers is far from over, and Mira's mysteries continue to inspire both scientific curiosity and a sense of wonder. With these questions in mind, we now turn to the next chapter of Mira's story, exploring its potential connections to the search for extraterrestrial life and the broader implications for our understanding of the universe. Now turning to the possibility of life in systems like Mira, we enter a realm of speculation that stretches the boundaries of our imagination. Could a star as dynamic and unpredictable as Mira host environments capable of supporting life? While the idea may seem far-fetched at first, the search for extraterrestrial life often leads us to consider the most unexpected corners of the universe. Mira's unique characteristics, however, present significant challenges to the existence of life as we know it. One of the primary obstacles is Mira's extreme variability. The star's dramatic pulsations cause its brightness and temperature to fluctuate wildly over a period of approximately 332 days. Such instability would make it difficult for any nearby planets to maintain stable conditions necessary for life. Imagine a world where the intensity of sunlight changes drastically over the course of a year, leading to extreme temperature swings and unpredictable weather patterns. These conditions would pose a formidable challenge to the development and survival of life forms. Another factor to consider is Mira's intense stellar winds and the massive tail of gas and dust it leaves in its wake. The constant bombardment of high-energy particles and the presence of a dense, turbulent environment could strip away any protective atmospheres from nearby planets. Without a stable atmosphere, the chances of life emerging and thriving diminish significantly. Additionally, the heavy elements ejected by Mira, while enriching the interstellar medium, could create hazardous conditions for any potential life in its vicinity. Despite these challenges, the search for life in such systems is not entirely without hope. Scientists have discovered extremophiles on Earth organisms that thrive in environments once thought to be inhospitable, such as deep-sea hydrothermal vents or acidic hot springs. These discoveries have expanded our understanding of where life can exist and what conditions it can endure. If life can adapt to such extreme environments on Earth, could it also find a way to survive in the chaotic surroundings of a star like Mira? Moreover, the presence of Mira's binary companion, Mira B, adds another layer of complexity to this question. The interactions between the two stars could create unique conditions, such as regions of stability or even the potential for tidal forces that might generate heat on nearby planets. While these scenarios remain speculative, they highlight the importance of considering all possibilities in the search for extraterrestrial life. As we continue to explore the cosmos, Mira serves as a reminder of the incredible diversity of stellar environments and the potential for life to exist in ways we have yet to imagine. While the challenges are significant, the pursuit of understanding these possibilities drives us to push the boundaries of science and technology. Mira's mysteries not only deepen our knowledge of the universe but also inspire us to keep searching for answers to one of humanity's most profound questions: are we alone? With this in mind, we now turn to the final chapter of Mira's story, reflecting on its enduring legacy and the lessons it offers about the wonders of the cosmos. Now turning to Mira's legacy, we find a star that has left an indelible mark on both the scientific community and the human imagination. From its discovery as the first known variable star to its role as a prototype for understanding stellar evolution, Mira has shaped our understanding of the cosmos in profound ways. Its pulsations, its comet-like tail, and its dynamic interactions with its binary companion have all provided invaluable insights into the life cycles of stars and the processes that govern the universe. Mira's legacy extends beyond the realm of science. It has become a symbol of cosmic wonder, a reminder of the vastness and complexity of the universe. For centuries, it has inspired astronomers to push the boundaries of their knowledge, challenging them to unravel the mysteries of stellar behavior. Its variability, once a source of confusion, is now a cornerstone of our understanding of how stars change over time. Mira's story is a testament to the power of curiosity and the relentless pursuit of knowledge. But Mira's influence is not limited to scientists. It has also captured the hearts and minds of stargazers around the world. Amateur astronomers eagerly await its periodic brightening, using it as a guide to explore the night sky and deepen their connection to the cosmos. Its name, derived from the Latin word for wonderful, perfectly encapsulates the sense of awe it inspires. Mira reminds us that the universe is full of surprises, waiting to be discovered by those who dare to look up. As we reflect on Mira's legacy, we are reminded of the importance of preserving our sense of wonder and curiosity. In a world that often feels small and familiar, Mira stands as a beacon of the unknown, urging us to explore, question, and dream. Its story is far from over, and as technology advances, we can only imagine what new secrets it will reveal. Mira's enduring legacy is not just a chapter in the history of astronomy. It is an invitation to continue exploring the infinite wonders of the universe. With this in mind, we now turn to the conclusion of our journey, summarizing the key insights we've gained and reflecting on the profound impact of this extraordinary star. Now turning to the conclusion of our exploration, let's reflect on the extraordinary journey we've taken through the story of Mira, the strangest star in the universe. From its discovery as the first known variable star to its mesmerizing pulsations and the discovery of its comet-like tail, Mira has proven to be a celestial marvel unlike any other. Its variability, once a puzzle, has become a cornerstone of our understanding of stellar evolution, offering a glimpse into the dynamic processes that shape the lives of stars. Mira's interactions with its binary companion, its rapid motion through space, and its role in enriching the interstellar medium with heavy elements all highlight its significance in the grand tapestry of the cosmos. It serves as a living laboratory, providing astronomers with invaluable insights into the late stages of stellar life and the intricate dance of binary star systems. Beyond science, Mira has inspired generations of stargazers, reminding us of the boundless wonders that await in the night sky. As we conclude, let's remember that Mira is more than just a star. It's a symbol of curiosity, discovery, and the enduring human desire to understand the universe. Its story encourages us to look up, to wonder, and to explore the mysteries that surround us. So, the next time you gaze at the stars, take a moment to search for Mira in the constellation Cetus. Let it remind you of the infinite possibilities that lie beyond our world. Before we part ways, I'd love to hear your thoughts. Have you ever spotted Mira in the night sky? What fascinates you most about this enigmatic star? Share your experiences and questions in the comments below. If you enjoyed this journey through the cosmos, don't forget to subscribe and hit the notification bell so you never miss an exploration of the universe's greatest wonders. Until next time, keep looking up, the stars are waiting. Now turning to our final thoughts, I want to thank you for joining me on this incredible journey through the story of Mira, the strangest star in the universe. Its pulsating brilliance, its comet-like tail, and its role in shaping our understanding of the cosmos have left us in awe of the wonders that exist beyond our world. But the story doesn't end here. It's just the beginning of your own cosmic exploration. I'd love to hear from you. Have you ever spotted Mira in the night sky? What fascinates you most about this enigmatic star? Share your thoughts, experiences, and questions in the comments below. Let's keep the conversation going and inspire each other to look up and wonder. If you enjoyed this journey through the stars, don't forget to subscribe and hit the notification bell so you never miss an exploration of the universe's greatest mysteries. And if there's a celestial wonder you'd like us to dive into next, let me know. Your suggestions could be the spark for our next adventure. Until then, take a moment to step outside, look up at the stars, and let Mira remind you of the infinite possibilities that await in the cosmos. The universe is vast, mysterious, and full of stories just waiting to be discovered. Keep exploring, keep wondering, and keep looking up. The stars are waiting.